Wait. Are you under the impression that sunsets don't work on a flat Earth because the angular size of the sun should change drastically as it moves away from us? Well, this video's for you. We're not only going to go over how the sun's size does actually change with a solar filter, but we're going to use an analogy to show that it should change slowly and not rapidly, like a lot of the globe proponents suggest. I'll simply use my hand to demonstrate this. If I put my hand right up in front of this camera, you see how it's really big? And then you move it away and the angular size changes very quickly? That's a demonstration of things changing rapidly because they're close to you. If something like the sun is already at a great distance away from you, its angular size is going to change very slowly. Hence, if I was already a mile away from you, I put up the same hand and I started moving towards or away from you, it would change slowly. This is why the sun's size does not change drastically. It leaves our view of perspective before it can change size extremely. Are you waiting for me to show you the actual size of the sun changing, even with a solar filter? Check out this video and we'll talk about it after.
There's a few of them you find, and one of them is from a channel that's actually trying to prove that the sun doesn't change sizes. And they share their footage. They don't do any comparison of the before and the after. They just share the footage. And when you watch it, it looks like there isn't a very big size change. But if you take screenshots and zoom way in and compare these, you can tell pretty instantly that there's a significant change in size.
Isn't that hilarious? Some glober actually did all the work for us, showing that the angular size of the sun does change even with a solar filter. You can see here's another demonstration. Solar filter was used. Size changes over the course of a day. I'd like to quickly and swiftly destroy the ideology that the sun shouldn't set now, because I know the opposition's going to be crying about it in the chat now that I've destroyed that it does change angular size. The sun, or the moon, as they get further away from you, they lower in perspective. This graphic very easily demonstrates this. So the sun's elevation relative to us stays similar, but because we have a terrestrial view of a celestial object, it lowers in our perspective due to point perspective. Now, you may ask, what is point perspective, Caleb? We don't see in Euclidean geometry in completely straight lines. We see in hyperbolic geometry. Hence, the ground ramps up and the sky ramps down, creating a vanishing point. So again, as the sun gets further away from us over the course of a day, it lowers in perspective and disappears from the bottom up, similar to this coin on a table. As you move it away from an observer, everything disappears from bottom up. It's not exclusive to a globe Earth model. Now you may ask me, Caleb, why does the sun even go around our level plane? And I'd have to reply with, I have no idea. I cannot use the scientific method to demonstrate how the sun is being propulsed around our level plane. But if you map all of the wandering stars, or planets as they call them today, over an azimuthal projection, you'll get these geometric lines that seem to be following these ley lines on a magnetic field under a supercell. So maybe everything's magnetically propulsed by the perturbation that is coming from the North Pole. Just a guess. Just a reminder to the globers, all celestial elevation angles require a flat Earth assumption. The sun, over the course of a year, lowers and highes dependent on what season we're in, and gets closer and farther away from the center of the Earth, causing temperature differentials over the course of a year, being warmer and colder. Also, the sun does not look like this ever when we look at it. If you look at the sun with a solar filter, it actually looks like this. Just to warn everybody. I think that's pretty much all I have to say.